Hi guys, it's Talha here again today. So today we are going to learn some math, some calculus, and then after that, if we have time, we are going to learn some fundamentals of computers, the topics which I missed yesterday. So in maths and calculus, our first topic is going to be about composition of functions or composite functions. Composition of functions. Then we are going to look at what is scaling of graphs, scaling. We're going to look what is shifting of graphs. Uh, yep, we're going to learn these three things, and if if after discussing these three things, if we have time, we are going to learn some fundamentals of computer, and in that we are going to learn what is flash memory. What do you mean by SSD? And then we'll talk a little bit about miniature hard disk drives, and the and some of the benefits of SSDs over hard disk drives. So first, let's discuss what are composite functions, which we use the term composite function in calculus. So basically, as I explained in earlier videos, what is a function? Function is composed of two variables, x and y. X is an independent variable and y is a dependent variable. So f of x equals y. So this right here is a function. Now, what is a composition of a function? You use the term composition when you combine two functions, or for example, you say that g of f of x, So that means f of x is a function of g. f of x g f of x G is composed of f of x. G is composed of f of x, and that is, you can say, equal to y. So here composition means that f of x is a part of g. Now the tricky thing in here to remember is that uh, f of x, the x is going to be the domain of f of x, and the range of f of x is going to be the domain of g of x. So basically, let me repeat that again. So you have x as the domain of f of x, and then whatever the range of this f of x is, that will be the domain of g of x. So when you combine a function, their domain and range has got to be its domain is going to be the range of this f of x, and it has to be a set of all real. It has to be, it has to produce a range of real numbers, and then its range is going to be whatever its domain is going to be. So its domain is going to be the range of f of x. So it's basically repeats two steps. And you can also have uh, many functions combined into one. For example, you can say you have g of f of x, and then G is composed of h of x, and then h of x is composed of j. You can have many functions combined together, which we are going to study later, but for now we are just going to study two functions combined together. And mathematically, or if you want to when you want to write it not in a mathematical term but more of to give an explanation, you can write it as g of x. So you create a hollow circle, and you write g of x, or any function name you want to write. So this means that g of x and g of x means that g is composed of f of x. F of x is a part of g of x. Now that was about composition of functions and how we do it. And now, for example, let me give you guys an example. For example, f of x is equal to 2x, and g of x is equal to g of x is equal to x square. Now, for example, we are to solve this question that what find g of f of x, or find g of x of these find g of x when you have f of x equal to x and you have g of x equals x squared. So how are we going to do that? We are going to do that by first finding what is f of x. If we are to find g of f of x or g of x, first we are going to look at what is f of x here. So here it is 2x, so that means g of 2x. And what is going to be the g of 2x? G of x equals x squared. So that means we are just going to replace x here. We are just going to replace x by the value here, because instead of x we have 2x, so we say we have 2x whole square, because we are going to replace x with 2x. So 2x whole square is going to give us 4x square. So this is going to be our g of x. 4x squared is going to be our g of x. So that is how you find. And if you want to do the other way around, if you want to find f of g of x, so g of x is your x squared and f of x squared, so you have to replace you just have to replace x by x squared, so that will be equal to 2x squared, because you're just replacing x. You won't multiply that, you won't take square of 2, because you're just replacing x by x squared, not 2x by x squared. Now let's discuss what is a scaling of graphs and shifting. So let's first discuss what is shifting. So shifting of graph, for example, there's a graph of y equals x squared and it's like this, but you want to shift this graph either to the top, either you want to shift this graph by account of or vertically up or down, or you want to shift this graph to the right or to the left for whatever reason. So how are you going to do that? The easy way, or you can say the way you are going to do that is, for example, we have a function, we have y equals f of x. For example, this is the graph of y equals f of x, that's obviously x squared. If you want to, so there are these properties where you based on these properties you can shift these graphs. So if you want to shift this graph vertically up, so you uh, add k, a constant, to the function. So if the k is greater than 0, it will move the vertically up based on the value you have given to the k. But if the k is less than 0, if the k is less than 0, if this k is less than 0, the graph is going to move down, vertically down. It's pretty much, I think it's self-explanatory that if the k is less, it will move down. If the k is greater than 0, it will move up. Now let's, for example, you want to move the graph from to the either to the left side or to the right side. So you're going to do that by adding a constant to the by taking the function, or by adding the constant inside the function of y. So that means y plus k. So you're going to do like this. You added k to the to the y. You added y plus k. First you found the function, the value of f of x, then you added k. But here you're going to add k to x, and then you're going to find f of x plus k, and then you are going to add k inside the function of x. But here it's opposite. If k is greater than 0, it's going to move to the left, and if k is less than 0, it's going to move to the right. So that was scaling of graphs. So that is how you're going to move to perpendicularly or vertically up, down, and horizontally right, left. Now here we have shifting of graphs. Scaling of graphs. So what does scaling means? Shifting means you want to shift the graph. Scaling means you want to scale the graph in a different position. So for example, if whether you want to compress the graph, or do you want, or you either you want to uh, stretch the graph. So stretching and compressing come into this category, the scaling one. So how do you do that? So there it also has some properties. So it has, for example, if you want to compress the graph, if you want to compress the graph, you are going to, if you want to compress the graph vertically, you are going to do y equals f of x, y equals f of x into c, or c f of x, and this c is a constant value. So when you multiply it by f of x, it's going to stretch the graph, vertically. And when you and yeah and when you will when you will divide it by f of x, it it's going to compress the graph vertically. And same is the case here. If you want to so this was the how you're going to stretch and compress the graph uh, vertically. And if you want to do it horizontally, you are going to multiply and take a function of f of cx, like this one, where you multiply it by the answer you get from f of x, but now you're going to take a function and calculate f of cx. So this is how you're going to shift the graph to the right. I mean, stretch the graph. Uh, this is how you're going to stretch the graph horizontally, and this f of c by x. This is how you're going to compress the graph horizontally. And when c is minus 1, this is a special case. And this, when c is minus 1, the graph is actually going to produce a reflection. So if it's on the right side, if it's on the right or a positive x-axis, is going to produce a reflection on the negative x-axis, for example. Or if it's on the positive x-axis, is going to produce a reflection on the negative x-axis. So or when c is minus 1, so that will get you y equals minus f of x, or you can say y equals f of uh, minus x. So this way you are going to get a reflection of your graph on the opposite side of the graph. So this was about composition of functions, scaling, and shifting of graph. Now let's discuss what is some fundamentals of computers. We have flash memory, SSD, and miniature hard disk. So first discuss what is a flash memory. So flash memory is a non-volatile, means it won't get erased by itself. It's a non-volatile memory which is in a solid state, means it has no moving parts, like unlike a hard disk where it had read and write hands. It has a moving it had hard disk had moving platers, but it does not have any moving parts. Instead, it consists of microchips which have electronic circuits. So based on these microchips and electronic circuits, the hard disk or the storage device is actually going to read the data out of it through these electronic chips, and there is no magnetic field in flash memory and solid state. So basically what SSD means solid state drive. And what is solid state means? Solid state means that it has no moving parts, solid state drive, and it remains the same, and it's non-volatile. So what solid state is based on the flash memory. Solid state drive or solid state uses flash memory as a storage medium, and the examples of them are is USB, which is universal serial bus. You have memory cards, you have express card modules, etc. So that was a flash memory drive or solid state drive. Actually, a flash memory or memory have certain advantages over over hard disk drive, because you have microchips and electronic circuits. The access time of flash memory and solid state drives is actually 80 times. Their access time is 80 times. Its access time is 80 times faster than that of a hard disk drive, because in a hard disk drive the read and write arm has to fetch the information, has to look out for the information. But in this flash memory solid state drive, the all of the information is stored in the microchips, and it's like it can provide you with the information in an instant, uh, because it is not that big, first of all, and also the information is stored in microchips, so it does not even look for the information. Then the information is all or the data is already stored on it. So it's 80 times faster, and also its duration, or the, you can say, the warranty, or it's going to stay good for almost 30 to 35 years, unlike hard disk, which can stay good, which can be in a good condition for almost 3 to 5 years. So its durability and reliability is more. But the only con of a solid state drive is that it's not really very reliable, or it's not really that safe, because hard disk drive is where you can store your data and information, and you can trust that it won't get erased, or it won't uh, get damaged that easily. But in a USB, in a USB, it's going to your information and data is going to damage pretty easily. And also in solid state drive, is pretty expensive gigabyte per gigabyte is very expensive. But as the rates go down, as the prices go down, I think every hard disk drive is going to be converted to the solid state drive, because of the speed, and because of the warranty. But reliability is will be always characteristic to consider, or reliability is always going to be a fact to consider about the SSDs. And we had another topic we had, that was SSD, flash memory, and then we have miniature hard disk. So the, the the miniature hard disk are used in cell phones, in portable media players, where you have the miniature hard disk. It's obviously miniature hard disk will store a lot lesser data than a usual desktop computer hard disk, but it's still really reliable, and it still works properly, and it is still going to store a lot of data for cell phones, for portable devices, and for mobile computers. So guys, I hope you guys like today's lecture, and you guys got to learn something from it. And knowledge is knowledge, it doesn't matter where you get it from. Thank you guys, thank you very much.